that way. So they, like crazy, they tried to make sure that we wouldn't get hold of a NAIDOP. They actually sent letters to all the communities, a little bit too late, to governments asking them to be very careful with their NAIDOPs, never to sell them to anybody, never to lend them to anybody. And then Barry manages to buy 2 NAIDOPs. We lent one from one community and then we bought 2 more. This is one of the 2 machines we bought for 3,000 euros. And then we got all the accessories to go with it, meaning the voting memory modules and the box to read the memory. You'll see that in a movie clip later. For $3,000 and a cake. And the cake was for, it was, I think it was whipped cream pie. But the cake was actually for all the accessories, because she wasn't sure what to charge for that, because she wasn't sure what it was worth. And Barry said, well, if I throw in a really big cake, is that okay? Well, I guess. Now, how we found this NAIDOP is by going through a list of all the municipalities that had merged. Because usually if municipalities merge, and I'm sure there's a lot of that happening in Germany as well, they have leftover accessories because they only need 1 set, and they may even have leftover NAIDOPs because they've lowered the number of districts or regions. So yeah, that's what happened. Basically what we told this community that we were buying them from is that our company was going to do workers' collective elections. And that as a large company, we would need to sort of multiple locations, you know, we would need these devices. And they were very glad to get rid of them because they were written off, and any money was just extra money. So we were doing these worker elections, and then once we got them, we figured out that, yes, we were only 6 people, maybe we don't need to do elections yet on a machine, so we sold them to the foundation. So we spent the month after getting the machine, hacking the machine, reverse engineering it in any possible way. And before I get into that, there's something to be said about that. We tried to convey this as often as we could, and we even succeeded on a few occasions, on quite a few occasions. But this isn't about computer security. It's not about whether some crazy crowd of 500 ninja fighters that breaks into government buildings can manipulate the vote. It's about whether we want to replace verifiability by blind trust in a system that we can't audit. But actually being able to prove that it could be manipulated got us the press to get that message across. There's a lot of stuff we did, and a lot of stuff about the hack is also in some of the movies I'm going to show you. So I'm just clicking through them really quickly and there's also a lot of it on the web. A lot of you probably have already seen some of the documents or have read some of the web coverage about it. There's a report that gives you all the technical detail that I'm skipping right now, just because I figured a lot of people would have read it already. But this is the key that needs to be kept in the safe when there's no election. That's actually the standing instruction for municipalities. As soon as the election is over, these keys go back into the municipal safe. If this was on your mailbox downstairs in your apartment building, you would complain to whoever rents you the apartment. And after every vote, the chairman of the commission puts it in a sealed envelope as sort of a magic gesture. Ceremonial, putting it in the sealed envelope. I'm going to be clicking through a lot of things here. Basically, this is what we found when we opened the box. When we unscrewed it, we found a motherboard. You'll see some footage of it later. We found a motherboard with a 68,000 processor, a really 68,000, not a 6820, nothing modern, just a really, really old 68,000. With the 40x4 LCD screen and the foil keyboard that you see in front of you. Oh, I can walk. Gee, I'm free. Underneath this piece of paper, which is covered by plastic, is actually 36 by 30 foil switches. So all the candidate names are printed on a piece of paper, which you order from the printing company. You don't do that yourself for local elections. And then the candidate names are printed on here, and then you press a candidate, it shows the name of the candidate, and then you press vote. And then it registers the vote both on one of these modules. I'll show them in some close-up later as well. Basically, just a little circuit board with 2 flash chips on them. And at the end of the day, it also prints out the results on a little thermal cash register printer, which you both see there, the 2 times 128 kilobyte flash and the cash register printer. For the operator, there's also a little console. This is what the poll workers press every time somebody gets to vote. They press this button. And if there's 2 elections, this device can handle up to 2 elections. They have 2 buttons. Like, for instance, you may be eligible to vote for local elections because you're a foreigner resident, but you may be not eligible to vote for parliament, in which case they will not press the second button. So, and there's a key. This is the famous high security key. And that's... And the document that comes out, the printout that comes out, actually has the status of a legal document. It's the proces verbal. It's the Dutch legal document that describes the outcome of the election, and it's actually signed by all the poll workers. Everything between these components is 74 series glue logic. There's no PALs for those of you into electronics. This is like the most bland, standard, vintage processor board that you could find. It's 1980s technology. It was probably designed, or predecessors of it were designed in the early 80s. And this particular version is from the late 80s. And then later versions of this device with minor modifications were also sold in all other European countries. So for instance, the German machine, the ESD1, is this NADAP, but with a slightly different box for the Wahlhelfer, because in Germany some polling stations are designated to get Wahlstatistik. So they actually get, they do statistic on sex and age group of the people coming to vote, and they have to press different buttons for the voters so that they can do statistics. And they incorporated that by putting more buttons on that little box. And they fixed some other things. And then another version of that device was then sold to France, where I think they replaced the EPROMs in it by flash. So you can actually by inserting a cartridge, you can change the ROM, which is real handy. And then a newer version of that then came back to Holland and is now the other machine that I just showed you, the ESN1, SSN1. So there's multiple iterations of it, but it's still the same 68,000 based system. They had to make changes reluctantly, basically because the only places they could get their parts was in electronics antique shops. They were running out of EPROMs, they were running out of through-hole components for a lot of that board, so they had to make new revisions basically as soon as the antique prices went up. So first we had to figure out a memory map. I'm sure you can't read this, or sort of. Part of this is reverse engineering from the board, and part of it is looking at the code, which I'll get into next, but basically figuring out where each line on that system went, figuring out what everything was. With IDA, you could actually disassemble the code, and then everything you see here, like read candidate info, that's of course meaning that wasn't there. That's meaning that we had to apply. And this is a tiny, tiny fraction. 256 kilobytes, which is what's in there. Only half of it is full, but that's still a lot of code if you have to go through it. Fortunately, we had some people that are very, very, very good at that. Jan Groenendaal said much, much, much earlier in the discussion, as he just became aware of our campaign, one of the claims we had made is, look, it's just a computer. And sort of to support that claim, we said, well, it can be programmed to honestly count the elections, to honestly count the votes, but it can also just as easily be programmed to dishonestly count the votes, or it could be programmed to play chess. And then as a reaction, in one of his PDF documents, Jan Groenendaal wrote, nah, can't do that. So, of course, this was our main challenge when we understood the machine. Now, it was a good test to see if we understood if we understood all the input-output. It was a good test to see if we really knew the machine well enough to start messing with the software that was already on there. But unfortunately, the machine only had 16 kilobytes of RAM. So we found a tiny old-style chess program that just fit, and we had to squeeze off a lot of tables. So its chess is pretty atrocious. But it knows all the rules, it knows en passant, it can do everything, but it's not a very strong player as a result of the 16 kilobyte limit. I'll show you some of that later because there's a little movie. But then we felt more confident, and we felt that we could actually mess with their software. And we called our software NADAP Power Fraud. And this is because they actually market their systems as NADAP Power Vote in English-speaking countries, or at least in England and in Ireland. So we figured Power Fraud was a fitting name. It's vote-stealing software that is very clever about when not to steal. Meaning, basically what we did is there's a little bit of EEPROM in there that stores settings, and it also stores an error log and an event log, which are really useless because it doesn't have a real-time clock. But there's some memory in there that we could use, and we actually shortened one of the logs so that we had 500 bytes left over. And in those 500 bytes, we put the 16-bit integers, how many votes we stole from which party. And we only stole if people voted for the number 1 of a party, which is what most people do. So we stole the votes, but we stuck them in a special place because we couldn't stick them on the module because we couldn't erase the module. Because the module can only be erased in the special box that they use to read the modules at the City Hall. So we couldn't write to that module, which was their idea of security. It was really implemented in a funny way. If you want to see how that was done, read the documentation because it's really interesting. So we couldn't read them. We couldn't write them to the blue module because we couldn't erase it. We couldn't take it back off again. So what we did instead is we stuck it in the settings ROM. And then at the end of the vote, when people closed the totals, when people said, okay, voting is over now, with the little key and then pressing some buttons, then we said, okay, let's now figure out if this was a real election. So if the election only lasted 2 hours, then it wasn't a real election. So we write back all those votes to the parties that they were supposed to go to. So if somebody does a little test election, if somebody only issues 50 votes, that wasn't a real election. So we write it all back to the party that we're supposed to go to. So any testing you do doesn't show that it's a fraudulent device. And if you go, we didn't do this, but if you go as far as to do stats on the timings between when you press the release button, when the candidate is pressed, and when the vote button is pressed, now, there's almost no way that a human volunteer that is issuing, say, 1,500 votes over an 8 or 10 hour period or 12-hour period at random intervals is not going to show similarities in the way he times those keys. So then it becomes a job for a robot to figure out if the software in that machine is still honest. So in other words, we've built software, or we've concepted software with that last point, we've concepted software that we could say, look, you're never going to find out that this software is in there unless you put it through a real election, or you use a robot, or you just take out the EEPROMs, which by then, of course, was the easiest way. So in other words, you can never figure out if this thing defrauds you or not. And in a real election, if you only take 5%, you'll never know. What we also did is our software had a little string in there, like one of the parties that's currently on the board there. People that are interested can play with this machine after we're done, or we can put it somewhere else. I'm here for 2 more days. We can even put it in the Hack Center and make a real workbench out of it. Basically, we wrote software that has a string in there, and if that string appears in the party name, then that becomes the recipient of the stolen votes, and you can also encode a percentage that you want to have. Like, I want 20% of all votes from random